C's closed contour around the origin, prove that a the power n over n factorial whole square equal to this right hand side, and also from this we have to deduce this second result also, right? And here if you notice that e the power az is in green colored, right? Because I have to take this to be as my function to prove this result. So let's start with the proof. Let's take fz to be equal to e the power az. Then what is nth derivative of this function? Let's calculate all the derivatives first. First derivative is e the power az into a, right? Second derivative is e the power az into a square. So on, the nth derivative becomes e the power az into a the power n, right? So that's why nth derivative of fz is equal to a the power n into e the power az. For z equal to 0 over here, I get a the power n into e the power 0, that is equal to nth derivative at z equal to 0, right? Which is a the power n equal to nth derivative at z equal to 0. We know that by Cauchy's integral formula, the integral over c fz over z minus z naught the power n plus 1 dz is equal to 2 pi iota over n factorial and the derivative of the function at z equal to z naught. Now here z naught is 0, right? So what is nth derivative at 0? Taking 2 pi iota over n factorial to the other side and putting the value over here for z equal to 0. So I get n factorial divided by 2 pi iota integral over c f of z divided by z naught is 0 over here n plus 1, right? And what is f of z? It is e the power az, right? Let's get back to our result. Here I'm having an divided by n factorial, right, in the left hand side. So let's take this n factorial to the other side. So I'm taking this n factorial to the denominator of a the power n, right? So an over n factorial is equal to 1 over 2 pi iota integral over c e the power az divided by z the power n plus 1. Now in this result, a the power n over n factorial is multiplied to the right hand side and also to the left hand side. That is why there is square over here. So let's multiply a the power n over n factorial on both the sides. So multiplying a the power n over n factorial on both the sides, I get square on the left hand side and on the right hand side 1 over 2 pi iota into a the power n over n factorial integral over c e the power az divided by z power n plus 1 dz, right? Or I can also write this as 1 over 2 pi iota into 1 over n factorial integral over c, taking this an to the inside of the integral, into e the power az divided by z the power n plus 1 dz. Please mark this as 1. Now since this 1 is true for all n equal to 0, 1, 2, 3, right? So this is our first result. Now we have to deduce this one. That means I have to take the summation on both the sides, right? So taking summation on both the sides, we get summation n going from 0 to infinity a the power n divided by n factorial whole square is equal to 1 over 2 pi iota, and because the summation is on n, so 1 over n factorial should be inside, integral over c a the power n e the power az divided by z the power n plus 1 dz. So this is further equal to 1 over 2 pi iota integral over c, taking the summation inside from 0 to infinity a the power n e the power az divided by n factorial z the power n plus 1 dz. And because this e the power az is independent of n, so I'm writing this outside of this summation. So this is further equal to 1 over 2 pi iota integral over c e the power az summation n going from 0 to infinity. Now z the power n plus 1 can be written as z the power n into z. So I am taking a over z the power n together. So this is a over z the power n divided by n factorial into dz divided by z. Further, this is 1 over 2 pi iota integral over c and e the power az. Now what is this summation now? Because I know that what is e the power z? This is summation n going from 0 to infinity z the power n divided by n factorial. So from here I can write this summation as e the power a over z dz divided by z. So this is equal to 1 over 2 pi iota integral over c, collecting the terms e the power, yes it is a into z plus 1 over z into dz divided by z. So this is equal to further. Now if I take z to be in the polar coordinate form, so this is z is e the power iota theta, then dz becomes e the power iota theta into iota d theta, right? And dz over z becomes iota d theta because z is e the power iota theta. So because z is in polar coordinates, the integral is on the limits from 0 to 2 pi, right? So this is e the power a into e the power iota theta plus e the power minus iota theta into this is iota d theta. And also we know that e the power iota theta plus e the power minus iota theta divided by 2 is equal to cos of theta, right? So I'm going to use this result over here. This iota is cancelled out with this one and we get 1 over 2 pi integral from 0 to 2 pi, and this is e the power, yes, a into 2 cos of theta d theta. So this is equal to 1 over 2 pi integral from 0 to 2 pi e the power 2a cos of theta d theta, right? Hence the result. Okay, thank you.